Hello, my name is Kai Mitchell, student ID 12160908, and here is my assignment 2 physical hardware solution. So here's my VS Code. We're going to go through that first. It's the same code I used in Tinkercad. So first it defines the pins, it then sets up the digital pins for motor and buzzer control. It then configures the timer for fast PWM on PD6. This function initializes the USART, Universal Synchronized Synchronized Receiver Transmitter for serial communication. It then sets a function to receive a character over USART, then a function to transmit a character over USART, a function to send a non-terminated string over USART, one character at a time, a function for the buzzer or LED indicator, so it turns on for 2 seconds and turns off, a function to initialize the ADC, and another function to perform a single ADC conversion and return a result. And moving on to the main method, we set up this method here is commented out since it's only used for the Arduino, for the Tinkercad simulation, and it's not needed for the physical Arduino. So we set up methods here. We set up the digital pins, the PWM timer, the USART, the ADC. And then we have some main method variables, so ADC value as a string, voltage as a string, the serial message, the ADC value received from the potentiometer, the voltage value received from the potentiometer, and the ADC value scaled for PWM. Okay, so going into the start loop, it waits till K is received. Once K is received, it sends this message out, motor controller by Kai Mitchell, and then does the buzzer for 2 seconds, then breaks, and then it sets the motor direction forward. It reads the ADC value, converts it to a string, calculates the voltage, converts the voltage to a float, scales ADC value to 0 to 255 for PWM value, so it can be set as the duty cycle here. And then it prints out this message prints out the ADC value, then the voltage. Okay. Then if we come down here to look at the physical circuit, so first we have a fan. Coming around here, you can see the battery in the background here. There's a potentiometer there. Over here you can see a buzzer. Here is the motor board controller. Here's the Arduino. So for the pins, this pin here connects, which is pin 2, digital pin 2, it connects to input 1. This pin here, pin 6, connects to the enable pin of the motor controller, and we have pin 7 connecting to input 2. Then this pin here connects to the buzzer, which is digital pin 9. Then the analog pin 2 connects to the middle pin of the potentiometer. Then these pins here, the black one is connected to ground and the ground rail. Red one is connected to the 5 volt and the 5 volt relay, the breadboard. Okay, so I'm going to move on. Just going to leave this here so you can see the fan. So I'm going to plug in the Arduino. Lights up. I'm then going to upload it. So the terminal's here. Just going to go through the code, going to wait a few bits. So it's uploaded successfully. So I'm going to then open the serial monitor. I am then going to enter P in the serial monitor, nothing happens. L, nothing happens. Okay, if we enter K, hear the beep. Okay, at the moment it's at 0 volts. Okay, so if we adjust it slowly, you can see the voltage reading start to change and the ADC reading. At the moment it doesn't have enough volts to move the motor. You'll start hearing a slight electrical E as I turn, as the fan tries to get off momentum to start spinning. So the motor has enough, you can see the motor slowly getting momentum when it spins to life. If I reduce it down a tad again, it should have some momentum and some inertia to keep moving. It just takes a more force. If I reduce it down, you can see the fan is slowing down slowly and has a bit of inertia to keep spinning, but it ends up stopping once I go around 1 volt. But around 1.4, it starts spinning. Right, so I've increased it to 2.4 volts now, which is at 2.5, and this is about halfway. It's slowly spinning faster. I'm not sure if you can hear the sound or not. Max out the voltage. It's reading 4.99, which is just due to some rounding error. It should be about 5 volts. Or maybe the physical components as well. If we reduce it back down, slowly reduce it down all the way. You can see it slowly stops. Yeah, that is my solution for assignment 2. Thank you for watching.